We have a rectangle, PQRS, and inside it, there is a circle with center O. The circle touches the left side PS at E and the bottom side SR at F. We are told that PE is 6 units and ES is 10 units. On the right side, QR, the circle meets the side at 2 points, U and V, and the horizontal line through the center O meets that side at T. Our goal is to find the area of the entire shaded region, which is the rectangle. So let's start with the dimension that we can determine immediately. Look at the left side PS. This side is made up of 2 parts, PE and ES. We are given PE equals 6 units and ES equals 10 units. Therefore, PS equals 6 plus 10, which gives us 16 units. So the height of our rectangle is 16 units. Now the area of a rectangle is length multiplied by width. So eventually we will need the other dimension, namely SR. At this point, that width is not known, so our main task is to determine SR. Let's look carefully at the circle and use the information about the points of tangency. I'm going to connect the center O to the point E, and also connect the center O to the point F. Now notice something important. OE is a radius of the circle because E is a point on the circle, and OF is also a radius because F is another point on the circle. Since both are radii of the same circle, they have equal lengths. More importantly, whenever a radius is drawn to a point where a line is tangent to the circle, that radius is perpendicular to the tangent line. In other words, the radius makes a 90-degree angle with the tangent. Here, PS is tangent to the circle at E. So, OE is perpendicular to PS. Therefore, the angle OES is 90 degrees. Similarly, SR is tangent to the circle at F. So, OF is perpendicular to SR. Therefore, the angle OFS is also 90 degrees. Now let's put these facts together. We have the 4-sided figure SEOF. The angle at E is 90 degrees, and the angle at F is 90 degrees. Also, SE is 10 units because ES was given as 10. And because OE and OF are both radii, they are equal. In fact, the geometry here tells us that this little region, SEOF, forms a square. So the side OF has the same length as SE. Since SE equals 10 units, OF equals 10 units. And because OF is a radius, the radius of our circle is therefore 10 units. So, we have established an important value. The radius is 10 units. If this reasoning is making sense so far, take a moment to like the video and subscribe for more geometry problems like this. Now let's move to the right side of the rectangle, because this is where we can determine the missing width. The horizontal segment from O to T is perpendicular to the chord UV. Remember a useful circle theorem. When a radius, or more generally a line from the center of a circle, is perpendicular to a chord, it bisects that chord. That means the chord is divided into 2 equal parts. So because OT is perpendicular to UV, we know that UT equals TV. Now let's determine the value of UT. Notice that PE is 6 units. The point E lies on the same horizontal level as the center O, and T lies on that same horizontal level on the opposite side of the rectangle. Therefore, The vertical distance from the top side PQ down to the horizontal center line is the same on both sides. In particular, the distance from U down to T is equal to PE. Since PE equals 6 units, we get UT equals 6 units. And because OT bisects the chord UV, TV is also 6 units. So the upper half and lower half of the chord are both 6 units long. Now we need to find OT. To do that, connect O to U. Since U is on the circle, OU is a radius. We already found the radius to be 10 units, so OU equals 10 units. And we now have a right triangle OTU. The hypotenuse OU is 10 units, and one of the legs, UT, is 6 units. Let's call the remaining side OT, x. Now we can use the Pythagorean theorem. The Pythagorean theorem says that in a right triangle, the square of one leg plus the square of the other leg equals the square of the hypotenuse. So in this triangle, we have x squared plus 6 squared equals 10 squared. Now simplify the powers. 6 squared is 36, and 10 squared is 100. Therefore, x squared plus 36 equals 100. Next, subtract 36 from both sides. This gives us x squared equals 100 minus 36, which is 64. Now we undo the square by taking the square root of both sides. The square root of x squared is x, and the square root of 64 is 8. Therefore, x equals 8 units. So we have found that OT equals 8 units. Notice that this is also exactly the familiar 6, 8, 10 right triangle, so we could have recognized the Pythagorean triple directly, but using the theorem makes the reasoning completely clear. Now we are very close to finding the width of the rectangle. We already know that SO is 10 units because it is one side of the square formed near the lower left corner, and we have just found that OT is 8 units. Since T lies on the right side of the rectangle, the distance from O to the right side is 8 units. Therefore, the entire bottom side, SR, is made up of SO plus OR, or equivalently, the 10-unit distance from S to O plus the 8-unit distance from O to the right side. So SR equals 10 plus 8, which gives us 18 units. Therefore, the width of the rectangle is 18 units. We already found the height earlier. Now we can calculate the area. The formula for the area of a rectangle is area equals length multiplied by width. Substituting our values, the area equals 18 multiplied by 16. Let's multiply this carefully. 18 multiplied by 16 can be written as 18 multiplied by 10 plus 18 multiplied by 6. 18 multiplied by 10 is 180, and 18 multiplied by 6 is 108. Adding those together gives 288. Therefore, the area of the shaded region, which is the entire rectangle PQRS, is 288 square units. So our final answer is 288 square units.